our last data type, simple data type, is going to be enumeration. So we can think of enumeration as, well, we live in Vegas, so say we want to like represent a deck of cards in our program. We could have something like values, right? And values are going to be like, what can a card have? 2. Whoopsies, that's not a 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, ace. We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12? Isn't there 13 in a suit? Okay, that should be it. Oh, Jack. That's right. Jack. Can't forget Jack. Jack, queen, king, ace. And then we have suits, which are going to be hearts, diamonds, clubs, and spades. So we don't want to use something in the computer to represent, say, like a char only, because, you know, a char could be anything. We could put like A in there. We could put B in there. But we only want to use these values. And then we could say, represent these with a string. But if we did that, you know, you could put in things like apple to our variable there, which we don't want. We only want these and these to be able to go into there. So how can we restrict that? Well, we can use enumerated types. So we could say, make the syntax for enumerated type is going to be enum. You're going to have your identifier. And then you're going to have a list of possible outcomes. So outcome all the way up. I'll put it in there twice just to drive it home. Outcome, all the way off into infinity. So how could we do this for our previous examples? So for that previous example up here, we had values. So we could say enum values equals 2, 3, whoopsies, 4, 5, 6, 7. I'm just going to go to the next line. 8, 9, 10, Jack, Queen, King, Ace. And then we could say like enum, or we could make a variable called values. We'll talk about how to make variables later. Next class. We could call it, say, V. I know that's a bad name, but just for the sake of time, we'll call it V. And we can call it equals 2. And it will put a 2 into there. But if we said that it equals R, we would get a compiler error because that is not a value in here. And then we can also do the same thing for our suits. But say we did something like enum shade. And we said there was a shade called light and dark. And then we did enum called weight. And we also had light and heavy. And then we were like, all right, I want to make a variable called shade. And I want to call it S, just for sake of time. And I want to put light in it. What's going to happen? Well, we're going to have a crash. Because we have light here, we have light here, and when we say, hey, let's make it light, it doesn't know what light it should be. Is it shades light? Is it weights light? It has no clue. So we need to talk about one last operator for today. It's called the scope resolution operator. And that's just going to be 2 colons next to each other. And you would say something like, shade scope resolution operator light. And that would tell your compiler, I want shades light, not, well, oopsies, that's weights light. I want shades light, not weights light. That's all this scope resolution operator right here is going to do for you, is tell you, differentiate between shade and weight. And you could also do something like weight W equals weight light, and you'll be okay. But if you did something like let's see, copy. If you did something like weight light, this would crash. Well, it wouldn't crash, but it would cause a compiler error when you try and compile your program with the GCC compiler. And that's all we really have time for today.